Hello, welcome back. Today we have 88 merge sorted array. It says here that we're given two integer arrays, nums1 and nums2, and they're both sorted in non-decreasing order. Basically, they're sorted. And two integers m and n representing the number of elements in nums1 and nums2 respectively. We are to merge nums1 and nums2 into a single array sorted also in non-decreasing order. So everything is sorted, and the final sorted array should not be returned by the function. It does say do not return anything. Instead, we need to store inside the nums1. Modify nums1 in place instead. And to accommodate this, nums1 has a length of m plus 1, where the first m elements represents the elements that should be merged as part of nums1, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Okay, so if we take this example here, the main idea is that everything, nums1, nums2, along with the output, everything is sorted. The second idea is we need to sort in place. We need to combine these two numbers all inside here, all inside nums1. And we are returning nothing. We are just updating this guy. Okay, so let's start. Let's have the number or the array that we care about, which is the one we're filling, which is nums1. Let's add that here. We'll initialize some indices 0, 1, 2, 3, 4, 5. Where remember, M3, this represents the three numbers we are merging, and this represent the extra space we have so that we have both. Okay, and then so let's start from the end of both and the end of our target. Well, okay, so end of both. So the last number in consideration from both, because everything is sorted and we want to fill also from the back the larger number and then go left bound, for example. Okay, so 3 and 6. Which one's larger? 6 is larger, so let's fill this with 6. Okay, we use that guy up. Which one's larger? And then now we're here. Maybe the coloring is bad. Let's use that. Okay, we're still here. Which one's larger? 5 is larger. Okay, let's add the 5 here. And then which one? And then pointer moves to 2. 3 versus 2. 3 is larger, so let's add the 3 here. Okay, now this one is here. 2 and 2, they're the same, so let's take either. Let's take the one at nums1. Let's add that here. Mark that off. And then the pointer is here. Which one's larger? 2 is larger. Let's move that here. And at this point, note that nums2 is done. And the way we can handle that is by setting the number representing whatever is coming from nums2 as the minimum possible value, which is float negative infinity. And essentially to say, please ignore me, I'm done. Okay. And then here, nums1's value is 1. Is that larger than float infinity? This is out of bounds, so we say float infinity. Yes, it is. So you win. You get to go. And by this point, we're done filling our nums1, and we're done. We return this 1, 2, 2, 3, 5, 6. 1, 2, 2, 3, 5, 6. Okay. So if we translate this into code, we want to know m plus n. This is the size of nums1 essentially. And we want to iterate the indexes, so let's update m and n to be n minus 1, and n minus 1. Okay, because these are the sizes and we want to iterate its indices. And we're filling nums1 from the back. For I in range of the size minus 1, we want to fill from the last index. We're going to go until the beginning in reverse order. And we can pre-process saying, what's the number representing nums1? Nums1. Is it out of bounds, first of all? If so, we can say, you know what? Let's default to 2 minus n. If m, which we decremented, so that now I represent the index of nums1, if m is less than 0, otherwise, whatever nums1 is at that index. Similarly for 2, we can say, okay, if we're ever out of bounds, if we're ever done representing all the numbers, then we can use the minimum number as its representative. If n, which is the nums2, if n ever goes below 0, otherwise whatever nums2 is at n. And at this point, it's just comparing. So if 1 is greater than or equal to 2, then we can say, all right, fill me, I'm going in reverse order, fill me, which is nums1, at I, with whatever value is at 1, which is the larger or equal of the 2. And make sure to decrement me, my index, so that I move to the next position. Once I use, let's say, 6 up, we go to 5. Once I use 3, we go to 2. Okay. And otherwise, then that means 1 is not greater than or equal to 2. So we can fill my current position with 1. And once we do that, oh, nope, 2. Nums1 is the one that we're filling from the back. Nums1 at the index position will be 2. And then make sure to decrement the pointer of n. And that's it. This one we can submit. And there you have it. This is 88 merge sorted array. We're running this in O of n linear time. We're visiting the number at most once, and we're basically going from the back of nums1 and filling it from the back to the beginning. And space, of course, is O of 1 because we're reusing nums1 and we're just using some constant variables. Thanks so much. Happy coding. See you next time.